let us see the AC side current. We have already obtained the waveform of the AC side current. We also found out what is the RMS value, what is the RMS value of the fundamental, what is the RMS value of the harmonic component. Okay. So, the waveform is the waveform for say IB is one of the AC side currents. So, it has only 3 possible values. IB has 3 possible values, ID or minus ID or 0. So, it is equal to ID for 120 degrees, it is equal to minus ID for 120 degrees, and it is equal to 0 for another 120 degrees. So, the waveform is like this. So, it is either equal to ID or minus ID or 0. So, whenever it is equal to ID, it remains at ID for 120 degrees, and whenever it is minus ID, it is remaining at that value for 120 degrees, and it is equal to 0 for 60 degrees before going to ID, and it is equal to 60 degrees before going to minus ID. Okay. So, at what instant it goes from 0 to plus ID? Say this is the waveform of IB, alpha. So, alpha is the instant at which valve 3 is turned on. So, IB is non-zero only when either valve 3 is on, or valve 3 is conducting, or valve 6 is conducting. Okay. So, that is alpha. So, if that is alpha, what is the instant at which it goes from minus ID to 0? It is actually alpha minus 60, it is alpha minus 60. Sorry, minus ID to 0, alpha plus, alpha plus 300 is same as alpha minus 60, right? Now, this IB is the current that is flowing through the voltage source EB. See, we have a 3-phase voltage source connected in Y or star on the AC side. So, IB is the current flowing through the voltage source with voltage EB. So, what is the expression for EB? EB is root 2 by 3 V sin omega OT. What is the expression? See, we have been using one particular expression, that is sin omega OT plus 30 degrees. Now, let us take a special case. Alpha is say 0. Suppose alpha is 0. Okay. If alpha is 0, then if I want to plot EB, suppose I want to plot EB. So, where is the 0 crossing of EB? So, say negative to positive 0 crossing of EB. Say when I say alpha is equal to 0, this is equal to 0. Okay. So, and this is equal to minus 60 degrees if alpha is 0. So, I am assuming that alpha is 0. So, if alpha is 0, then where is the 0 crossing of EB? There are 2 0 crossing in each cycle, positive to negative, negative to positive. Suppose I take the negative to positive 0 crossing of EB, at what value of omega OT there is a negative to positive 0 crossing? Minus 30 degrees. So, minus 30 degrees somewhere here. Right. So, this is minus 30 degrees. So, suppose I take this duration of 60 degree interval, and if I take the midpoint of that, what is this midpoint of this 60 degree interval? What is the value of omega OT at this instant? 150. Okay. So, that is 150. So, this is 150 degrees. Then again, if I take this 60 degree interval and take the midpoint of that interval, this is, I am again taking the another interval where IB is 0, that is of width 60 degrees, midpoint is, so that point corresponds to 330. Okay. Now, my intention is to draw EB. So, if I draw EB, it will have a positive, negative to positive 0 crossing at minus 30 and positive to negative 0 crossing at 150, because minus 30 to 150 is of width 180. Then 150 to 330 is 180, again 180. So, EB is like this. So, this is EB. Now, I define one more quantity, IB1. IB1 is the fundamental component of IB. So, I have already shown IB. If I show on the same figure IB1, which is a fundamental component of IB. So, by definition, fundamental component is a sinusoidal waveform. See, any fundamental or harmonic component is sinusoidal waveform. Okay. So, if I take this sinusoidal waveform IB1, how is it related to EB in phase? It is in phase. It is in phase with EB. So, if I try to draw IB1, so IB1 is in phase with EB. Okay. So, IB1 is in phase with EB. So, this is the case if alpha is 0. Now, for any general value of alpha, okay. So, let us say let IB1 lag EB by say some phase angle. So, I will give some notation for this phase angle, say phi 1. Say I am using the subscript 1 because it is the angle by which the fundamental component of IB is lagging EB. Okay. Now, in general, for any value of alpha, can I relate phi 1 and alpha? See, what is phi 1 for alpha equal to 0? 0, 0. Now, if alpha is not 0, then what is phi 1? Suppose alpha is 10 degrees, what is phi 1? Huh? Alpha is also, if alpha is 10 degrees, phi 1 is also?
10 degrees.
Is that obvious? Yes. So, for any value of alpha, phi 1 is equal to alpha. So, can I say that phi 1 is equal to alpha? Okay. So, I mean I just introduced a notation phi 1, but it happens to be same as one of the notations already used. So, phi 1 is the angle by which IB1 lags EB. So, that happens to be equal to alpha. Okay. Now, we will use this result and get some more relations. So, if I take the converter, one, 3, 5, these are the val numbers, 4, 6, 2. So, this is our converter. The DC side is represented by a current source, a constant current source ID. The voltage across the DC side terminals is VD. The AC side is represented by just a voltage source, balanced 3-phase sinusoidal voltage source. Plus minus plus minus plus minus EA, EB, EC. So, we have expressions for EA, EB, EC. EA is root 2 by 3 V sin omega OT plus 150 degrees. EB is root 2 by 3 V sin omega OT plus 30 degrees, and EC is root 2 by 3 V sin omega OT minus 90 degrees. So, the current that is flowing here is IA, the current that is flowing here is IB, the current that is flowing here is IC. So, please note our converter is just consisting of 6 thyristor valves, nothing more than that. Whatever is shown as voltage source is a representation of the AC side, and whatever is shown as on the DC side, that is the current source, is the representation of the DC side, that is all. So, the converter is just these 3 legs or 6 thyristor valves shown within these red dashed lines. So, this is the converter. Suppose I take the instantaneous power consumed by converter on the AC side. What is this? The instantaneous power that is consumed by the converter on the AC side. Sorry? Yeah, It is just EAIA plus EBIB plus ECIC. EAIA plus EBIB plus ECIC. Now, what is the instantaneous power? See, why it is consumed by the converter? Because it is supplied by the voltage source. See, the current leaving the voltage source is leaving from the positive terminal. So, it is the power which is generated by the 3-phase voltage source and it is consumed by the converter. Suppose I take the instantaneous power generated by converter on the DC side. What is this? VD ID. Current is of course a constant ID, voltage is VD. Now, why we say power generated? We are taking it as VD ID. So, you see that ID is leaving the positive terminal. Okay. Now, what do you say about these two powers? They should be equal. See, the reason is the converter is lossless. Just because we have a lossless converter, can we say instantaneous powers are same? Not only that, the converter is lossless because all switches are ideal, and there is no storage, there is no inductor, there is no capacitor in the converter. Please note, see, if there is storage, the instantaneous power can just go in and not come out, or a smaller value of instantaneous power can go at some instant, but a larger value can come out because what is coming out can be from the stored energy. So, there is no inductor or capacitor in the converter. So, that is why the instantaneous power consumed by the converter on AC side is equal to the instantaneous power generated by the converter on the DC side. So, what I am trying to say is EAIA plus EBIB plus ECIC is equal to VDID. Now, when I equate these two powers on the AC and DC sides, I can also say that the average values of these are same. See, when two quantities are same, two instantaneous quantities are same, their average values is obviously same. Now, what is the average value of the instantaneous power which is consumed by the converter on the AC side? Okay, let me take the average value of, say, what I will do is I will just give a notation for this. So, I will call this power on the AC side which is consumed by the converter on the AC side as PA, A for AC. Suppose I call this as PD, both are instantaneous. Okay, PA and PD. PA and PD are same. But if I look at the average value of PA, now can I write the expression for this average value of PA in terms of the RMS value of this voltage? Say RMS value of the line to line voltage is V. Okay. So, can I write this in terms of RMS value of the voltage and RMS value of the fundamental component of the current? See, the currents has harmonics, but what is the contribution of harmonics to power? I mean, I just want to check whether you are familiar with this result. See, on the AC side there are sinusoidal voltages. Current is not sinusoidal, but current has harmonics also. So, what is the contribution of harmonics to power? Average power is 0. Now, when average power is 0 due to harmonics, so the only contribution is coming from fundamental. So, can I relate this average value of PA to V? Then the fundamental RMS is I1. We already have this notation I1. They are fundamental RMS on the AC side. And any other quantity? Cos of. So, we just now defined phi 1, cos phi 1 into, please note, this is AC 3-phase side. This is a 3-phase side on the AC. AC side is 3-phase. So, it is V is line to line RMS. V is line to line RMS root 3. So, it is root 3. This is something which you are all familiar with. See, suppose I had only fundamental current, this is the expression for power, root 3 into line voltage RMS into line current RMS into cosine of the phase angle difference. This is a well known expression. But in addition to fundamental, there are harmonics, but I am ignoring the harmonics because they do not contribute to power. Okay. Similarly, if I take the average value of PD, see what we just now wrote was the expression for the instantaneous value. What is the average value? It is nothing but I can write it in terms of the average value of Vd. Right. Okay. Now, I would suggest that you verify that these two are same. I mean, it is a known result, but you can just verify. So, just verify. What you need to do is substitute the expression for I1, substitute the expression for Vd, and try to verify that these two expressions are same. So, the average value of PA should be equal to average value of PD, obviously, because PA itself is equal to PD.